all the respected dignitaries here. Uh, Here, all the faculty members from the different institution across the India present here, research scholars, PhD MTech students, as well as Triple IT and our students here. I, Dr. Shrivishal Tripathi, on behalf of Triple IT and our fraternity in here, as well as the FTP coordinator here, I will welcome you all once again in this morning session of the fifth day here. This is the 13th technical sessions here will be discussed today in this session here. And before we move on for the technical part here, let me brief you about the agenda for the today's activities. I have already shared in the minute to minute plan with all of you here. However, I would like to remind you. So first, today's first session, there will be two technical sessions. One will be anti 5G. It will be taken by me here. Another session after that, it will be again on IoT and wearable antenna here. It will be again taken by me here. And that after that, session 15 will be from 2:30 to 3:30 here, which will be taken by Mr. Nitin Srivastava, meditation yoga teacher here. And after that, we will have for a short online quiz test here. So link will be shared to all of you on your email IDs here. You need to be responsive to them here, as well as in the chat box too here. We will share this online quiz mail here. After that, half an hour time will be regarding the feedback here, where one link I would share from the coordinator side here. It will be shared in the post session here. You can say 2:30 to 3:30 session here. We will share the attendance as well as the this feedback. Both link will be shared with you. And after this online quiz, and most important things, you need to also provide the feedback on the AICT websites here. So from the AICT portal here, you all have registered for this course here. The same way, you also need to go to that portal here, login, and this FTP here, you need to click it, and then there will be feedback section here. So at that section, you need to provide the feedback related to this FTP here. You need to provide, and after that, we will have a validation program, and we will close this FTP here. So with this proceeding, I hope you all are aware here. Just was a reminder from my side. So with this, now I'd like to start the today's technical session here. This is for the antenna for 5G here. Before we move on, let me share the slides. Meanwhile, if you have any query, you can ask me at this stage, or later on you can also ask. Or if you have any query, you can always have the liberty to go through the chat box here. You can put your query from there. Okay. As a speaker of this session here, I welcome you all again, and very good morning to all the participants who are present for this technical talk here. So in this session, we are going to discuss a few of the brief outline regarding the antennas for 5G communication here. We will see in what perspective we are looking for, for the design of the antennas here in the reference of 5G technology. This part we will look here in the discussion. Along along with that, we will try to see what are the technical aspects when we go for the antenna design in the context of 5G, or what are the key parameters which we will looking here related to the 5G technology and design here. So this part we will be looking explicitly in this discussion here. And before we move on to the 5G context here, let us remind you all few of the very basic related to the antenna technology here, which we discussed earlier too. but very quickly we'll go through these slides here within 5 to 10 minutes, and then we'll move on. So that if any one of missed that first session introduction to IoTs here part here or IoT antennas here, then he can also patch up here. So once we talk about the antennas here, we could define antenna as a transducer. As a functioning of the antenna, we could always say, because when you say the transducer here, it means it converts energy from one form to the another form here. And here the antennas operating principle, if you look here, the one end of the antenna will have the electric signal in form of voltage and current in other part here we see as the output here electromagnetic waves here. So this conversion is taking place through the antennas here. So that's why we could also look transducer here and the antenna also here. So some aspects people used to correlate it as a transducer. So here, but whatever say, this is not more important. Yeah, importantly, you understand the functioning here, what the antenna exactly do here in the communication system here. So when you say the antenna here, it provides, or you can say, mechanism for the conversion of electromagnetic waves from the electric signals here, or you can say converts the guided electromagnetic waves here to the unguided electromagnetic waves, and vice versa here. So at the receiver end, the reverse operation will be taken place here. So when you say the unguided wave here, so transmission line, coaxial cable, other things will be part of communication here. For any physical media which we provide for the direct communication here from source to destination. And when you say wireless medium here, or you can say unguided here, then there will be a channel which will be air in case of our general consideration here, or in the ideal case here, it will be vacuum here. So if you remember, when we talk about the antennas here, we discussed what are the scenarios when this radiation phenomena will take place here. So when we talk about this radiation, because this is the radiation which decide the importance of the antennas here in the communication system. Because irrespective of the fact, there are many components present here in the complete communication chain here. If we talk here, from starting from the antenna, LNA, filter, oscillator here, uh, power oscillators, VOs, VCO, others part will be also present here. But along with that, none of them work as a radiator here. They just energy flow take place here from one component to the another component to the next one here. So they will keep on propagating and floating here. But out of that, all the components we can say the antenna is totally distinct here in its nature as well as the functioning, because it converts the electromagnetic waves here to the electrical to the electromagnetic wave here. Because due to the antenna, we have the liberty for a wireless transmission here. If antenna is not present here, then you can think of how many wires in your surrounding will be present here. For each and every small communication, we need a small a piece of wire here for the communication purpose. So this will be limitation here, extreme here. So when you talk about the radiation mechanism here, so more formally we could define to create radiation, there must be a time where varying current as well as the acceleration or deceleration of charges here. If the charge is not moving here, so there will be not be any current because I is equal to dq by dt here. So current is proportional to the rate of change of the charge here. If charge is not changing here, then there will not be any current here. So it will lead to the no radiation case here. However, if the charge is moving with uniform velocity, and then if a wire is straight and infinite in extent here, then there will be still no further radiation here. Again, if we move on in case of another case, whenever the wire is curved, bent, or there is a discontinuity here, then these discontinuities causes a change in the current path here. This change leads to the radiation phenomena here. We will have some radiation. Or in the last case, if it is a time varying in the nature here, so it is oscillating here, then electric field and magnetic field both will exist here. So you can say time varying electric field will lead to the generation of the magnetic field, and time varying magnetic field will lead to the generation of the electric field. If one is present here, the other could be also observed here. This was all this phenomena is governed by the four fundamental laws here, which is governed by the Maxwell's laws here. here regarding the propagation of the electromagnetic waves. So whatever the electromagnetic waves are generated here, we all know that they propagate at a speed of light here. And when we are observing these fundamentals here, and these you should remember all these fundamentals, or you can say four Maxwell's laws have been inherited from the four fundamental laws here. So first two you can say based on the Gauss law, third is Faraday's, and fourth one is on Ampere's laws here. So all these fundamental laws were already present here prior to the Maxwell's, but main contribution of Maxwell was he just provided a unified theory combining all of them, and in the Ampere's law here is put a correction here. So those who have studied electromagnetic, they know here del cross H is equal to J plus del D by del T. So del D by del T is displacement current, and it is the contribution of Maxwell's here by correcting. So once we are dealing with the all the electromagnetic kinds of waves here, and we have to keep the movement here around their presence here. And in that scenario, when we are moving to the higher generation here, from the 4G to the 5G here, there's for the today's session topic here. Then if you see a few of the scenarios, and then if we come to the design here, it will be better to understand and what perspective we need to design the things here. Right. So let us discuss very briefly few of the aspects of the 5G technology here. Then we will try to correlate here what are the how these key components are important, and how we can keep note of those components here when we are going for the design of the antennas here. So, as there is a very interesting facts here, in 2021, 28 billion devices will be connected here, and out of those 28 billion, so 12 billion will be phones, PC, laptops, tablets, and 16 billion IoT devices here. Now you can think of when you are in your surrounding here, there are 28 billion devices here. So, what kind of network requirement it will leads to here? So this is not a very small number here, or it is a moderate number. It's a very huge number here. And with the upcoming time, this number will be keep on increasing here. And we also know, based on our understanding here, okay, when we talk about accommodating more number of devices for the service purpose here, or more kinds of services inclusion here for user perspective here, then in all those cases we require the bandwidth. Bandwidth is always which we look very critically or explicitly here, or it's a desired phenomena when you talk about any generation technology here, and that's why we need to keep on switching from 2G generation to 3G, 3G to 4G, and so on here. So if you try to understand the overall meaning of the 5G when you talk here, so we say the 5G means everywhere it will be need to be connected or from anywhere here. So whatever the information we need here, we could access it from anywhere, and whatever the places we are moving, I will be always connected through the network here. So these kinds of network, you have to plan it here. So based on these kinds of network planning here, we have to move on here. So, as per the rules or the guidelines here, which are the regulatory authorities have been proposed here in the context of present 4G technology here, as we all know that when you talk about the 4G here, we are generally working 2 to 3 gigahertz bands here. Here mainly in a few countries, 3 to 3.5 gigahertz band here, but still we are working below the 3.5 gigahertz here. But when we move to the 5G technology here, so there are multiple standards here which the people are proposing here. So in case of 6G, 5G technology here, if you go through literature here, then you'll find one standard which you talk about 3.5 gigahertz, another standard which you talk about the 5.5 gigahertz range here. So within that, if we common point is when we are moving from lower frequency to the higher frequencies here, there's one point which you need to note here. We are keep on increasing the bandwidth here. And why we are increasing the bandwidth? Because we need to accommodate more number of devices. We need to accommodate more services here. So, as we are also observing with the time, these services or the appliances, surrounding will be keep on increasing very exponentially here. So, we need a continuous more and more bandwidth here with the time progress here. So, the people are also, so the regulatory authority is also proposing uh, the frequencies here, keeping note of those requirements as well as the growth perspective here. So when we talk about the 5G here, so just we discuss few things. So now if we see from this pictorial view here, so a lot of doubt as well as will be clear, as well as a lot of clarity will be with us here. If you try to look what are these kinds of different technologies we are talking here, and what kind of specific application which will be linking through these networks here. And the most important is whatever the technology application we have listed, it are just a few. There are many, many more here compared to what we have just listed here. And these are the few of the popular technology with which we are very familiar, or those terminology are known to be in some aspects to us here. So here, if you see, when you talk about the 5G network here, so 5G network will be working as a backbone when all such kinds of application here, like your multimedia messaging, connected vehicles, video streaming, holographic watch, vehicular communication, Internet of Everything, implantable antennas here, or actually implantable wearables, smart farming, in-body network, nano IoT, so full autonomous vehicles, so everything from your uh, starting from your basic needs to the advanced needs, everything or every device will be connected through a one backbone of network, that will be the 5G here. And from this figure, you can take a note from here that if you observe these kinds of applications here, then you can see all these applications are different in the nature here. Correct. If you remember yesterday's talk here, what is Professor Vyas has given related to the IoT and the smart cities here, where you highlighted a few things related to these here. Because when you talk about such kinds of network here or the smart cities here, at that time we will talk about open software, open system here. So where because we need to integrate the systems here, where all of them will be working on the different protocols, and we need to provide a way so that all of them can interact with them here. But this is not very, because there is a one device working on another set of protocol, and the device working another set of protocols here. As a service provider or as a backbone agency here, I need to provide a way so that all of them will be uh, having a chance to interact with each one of them here. So this is looks easy, but here in the practical implementation, it is very challenging here. As the providing such kinds of robust solution which will be applicable, or you can say acceptable for all of them here, for all kind of services, all kind of applications here. It is very, very challenging here for the designers here. It leads to a lot of hardware related issues as well as the software related issue here. So where the CSC, EC, actually from the design perspective, you see the from the mechanical person here or the production purpose persons here, and take a lead role here in such kinds of network designing here. If you see a few of the key requirements when you talk about such kinds of network here. As the number of devices will be very high in the number here, and many of the devices, or you can say major chunk of those devices, will be having a interaction in the wireless mode here. So there is a highly likely for them here that they will be vulnerable for the attacks here. So security threats will be a common problem. So when you're going for such kind of network or system here, so it will be uh, bottleneck, or you can say a requirement here, to provide a strong security here, as well as with the highest level of reliability here. As we all know that when we are talking the protocols and the transmission here, there is always a chance here that based on the nature of the medium, some packets of data packets may be lost here. So how could you ensure that those kinds of losses associated with the packet will be minimized here? At the same time, the system need to be very responsive here, or you can say the latency part of the delay will be very low here or low here. Or if we need to access something from a database, it need to be like this here. Or if you want to go for the computation here, so even without knowing to us, this a lot of computation is taking place. All the computation will be done here within a click here. So those kinds of system reliability, such kinds of functionality here will be generally the requirement for the 5G perspective here. So as well as when we are moving ahead here to provide the services here to all those kinds of services, the applications here, we need to be extreme data rates. Channel capacity need to be very high here, and people are talking about terabits per second here. So now you can think now if people are talking about the Mbps speed here, correct? The Mbps speed we are getting here on mobile phone here. Now people are moving ahead from Mbps to the Gbps, then from Gbps to the Tbps here, terabits here. Now you can imagine okay, such kinds of speeds here, even you'll not have a chance to identify either these are coming through the direct download here or they're already stored at some place here on a desktop here. So the moment you say give the command, it will be automatically pop up here. It will be accessed and fetch up. It will be available to you, and you can enjoy the services here. So here, at the same time, how we are going to manage the complexity of such network here. When you are dealing with so many number of devices, one aspect we have we should not forget. Because to for the functioning of so many devices, we need to also power them here, or we need to find a mechanism where they will have the way to survive here. So here comes the ultra low energy here. So you'll be surprised, or maybe some of you know here the people are working on those kinds of models here, especially for the IoT devices or those kinds of application where the power requirement is low. So people are thinking as whenever we need to take the data from some of the sources. For example, if there is a node here, there is a remote node. This here. Suppose there is a remote node here, and there are some sensors or lying here. So we can assume there is key. It sensors here, and it will be keep on monitoring the data from its surrounding here, and it will having some kind of storage capabilities too here. So it will store the data here. And if I need to take the data here, then I will send a strong signal from this side here, and this signal will goes to this key here. And the moment the signal goes here, it will be such a way that whatever, as we all know, that when I need to transmit the signals here, I need to transmit a electromagnetic wave here. When I'm transmitting electromagnetic waves, indirectly I am also providing at some level some electrical or voltage signals here. So this electromagnetic waves, which is reaching to this key here, and it will, you can say, feed the power requirement of the sensors here. It will charge its battery here, correct? And whatever the information it will access here, based on that information will be again transmitted to the node station here. And this transmission will be taking place if the communication is coming here. It will keep on transmitting the pulse. It will keep on charging here. It will be sending the information here. So this could be a one way here. Another way could be it could be communicating as well as based on this communication of electromagnetic waves here. It will find a way to the energy harvesting concepts here. So energy harvesting concepts, we will have the mechanism to provide a charging functionality here for such kinds of devices. If you look at looking to explore these kinds of aspects here, so I can tell you that one of the two premier institutes of India's are working in this direction here. So you can find some of the reference works here from the ISC Bangalore as well as from IIT Delhi here. So these two places, few works on this swiped here. So means simultaneously wireless power and information processing both will be taking place simultaneously. Means power as well as the information. Both transmission will be taking place simultaneously here. this part will be taken place without a batteries here. So now people are thinking, and they've already few works is already initiated. Many research groups already trying to explore the future requirements and working very hard here to be responsive to those problems and provide alternate solutions for those things. And before we move on here, let us see a few of the key parameters related to the 5G different standards here. So I will not go each in every minute detail here. But before I move on here, one point I need to emphasize here. Here, if you see the second point here is related to the 5G, the carrier bandwidth here. In case of carrier bandwidths, if you see from the one version or one generation to the another generation when you are moving here, correct? Then you can see the bandwidth requirement here related to the cell here. So carrier bandwidth, whatever it is in the megahertz range here, 1.4 to 20 megahertz. Now it will be in our next jump here. It will be 5 to 40 megahertz. You can think of almost double we are talking here in case of next upgradation here. When we talk about the next for the next upgradation here, this bandwidth requirement will be from 40 to 200. So you can say jump of 5 times. And another interesting is if you go for the next generation of technology here, then this bandwidth requirement will be around from 400 megahertz to the 2 gigahertz. Now, from megahertz to gigahertz, jumping in terms of operating bandwidth will be there here. Now, you can think if you are looking for such kinds of enormous amount of bandwidth for the transmission here, then you can also get some instinct here. That these can, if at present few megahertz bandwidth, suppose 20 megahertz here, 20 megahertz bandwidth, we are able to communicate so many devices and we are able to support so many applications here. Now you can think if the bandwidth at our end is suppose 100 megahertz, 200 megahertz, or 1 gigahertz range here, then you can think of what kind of services or the future of technology will be here to facilitate in our daily life as well as the other transportation or you can say healthcare, agriculture, finance, banking, all such kinds of sectors here here to make it more technology friendly as well as technology oriented as well as to help them in their daily working here. So if you see the few of the key technologies here in the context of 5G here, then these are the technology, and on the top of it is massive MIMO technology here. And today's talk, we are going to discuss this massive MIMO or the 5G here, and millimeter wave technology, full duplex communication here, as well as the device-to-device communication and the heterogeneous network here. So a lot of ECE and CSC related work is present here in this context here. So generally, we will talk about the massive MIMO part here. Okay. So once we see this antenna array aspects here, so as a solution, people have sought how we can get this solution for these kinds of problems here. So when you are looking for the possible solution for these problems here, because the bandwidth is not present in the luxury here. So, corresponding to a technology with a single antennas, here we have the limitation. Beyond that, we cannot move on here. But what could be the other ways here to explore it further here or enhance it further here? So, these kinds of thoughts, or you can say, are the reason here which motivated the researchers to go from in an unconventional ways here to explore the new dimensions of the technology here. Nowadays, we are thinking the MIMO is the solution here, but if you see the perspective from 20 or 30 years ago here, at that time, all of things were happening in this with the single antenna system. So no one thought about the using multiple antennas in such a way so that so that when putting such kinds of arrangement here will be so much beneficial here, or these kinds of property we will have, and we could utilize them here. So, so these were are not so difficult thoughts here at this time here. But if you see those years here, then it was literally a new path here, I can say, when the people have started thinking to exploiting the multiple antennas characteristic here. So this thinking was generally ignited based on a few of the observation of antennas array technology here, as well as the people have when people they move from the lower frequency to the higher frequencies here. So these are the generally two observations. Based on these two observations, they explored a lot of new things here, new dimensions here. So let me say in a very simple way here. If you observe these two diagram here in this way, so you can see how this there is a both the cases there is an antenna system here, and corresponding both the antenna system this shows a beam here. Okay, so both the cases there is an antenna. It is feed up here, and both the cases it is transmitting further here. So you can say at the microwave here, this beam is very high here. Correct. So as the receiver end, if you see, this is our antennas here. It is receiving, but this is the area where the beam is reaching place here. Like it is transmitted to this antenna. When it comes to the receiver end here, this is the amount of beam here available. This is span. So you can think of whatever the coming in this region, and so once we see from this transmitter antenna, and another is the receiving antennas here, this side. So from transmitter receiver here, when it reaches to from this point to this point here, then there is some additional space here or area where this beam is coming here, but it is not very useful to us here because there's nothing, because we all the information we are gathering which is coming to this point here, correct. But whatever is coming in this part, with respect to the antenna system, it doesn't have a significant impact on it here. So people have thought, why we are going to waste this energy or the resources here. The point is because at this point we are using some power here. Based on that power here, we have generated electromagnetic waves here, and these electromagnetic waves are coming to here. So these kinds of these are the places where this energy, you can say, just wastage of energy here. We're not using it here. At the same time, so whenever the wave is propagating through the channel here, and it is going through a larger area here, so means it will be prone to all those kinds of interferences present in this channel window here, correct. So whatever the more the time you spend here in channel means, the chances for that beam to be affected will be more here, or the more the time you are presenting or more the area you are covering here, so the chances for the interference or the affected by the channel will be keep on increasing here. It is highly likely here that the more the interaction with the channel will distort the wave more and more here, or more in the wider area of presence here, so this chances will be further enhanced and more here. So people have thought when you are going for millimeter microwave to the millimeter wave here, so there are some properties of the frequency itself here, that when you have moved from the lower frequency to the higher frequency, some kinds of directional phenomena is observed in those frequencies here. That this motivated the people to explore this directional behavior here and try to exploit this behavior in a further refined way for our application requirement. Why I'm saying the application requirement? Because as we are moving from the one generation to another generation here, we need to support more number of devices, more number of applications here, and these applications are keep on increasing here. And we also know that when we move from the lower frequency to the higher frequency, our spectral range is also decreases here. Suppose from roughly if I say, if there is a lower frequency BTS here, if you many of you have noticed or observed here this one. If you remember, so when you talk about 2.5G generation here and the BTS tower are present here. So in a city, at the one place there was a tower here, and around uh, 3 to 4 kilometer range here there was a one BTS tower which was working alone here. But nowadays, if you compare with the present scenario and the number of BTS towers, you can see after every kilometers or within that, maybe within a kilometer you will find two or three here, or at least after a kilometer you will find a tower somewhere placed here on the rooftop or some other public places here. Here. Why? What happened all of a sudden here when you move from the 2.5 to 3G and 4G here? So we need to install so many towers here. So here the concept comes here when you are moving from one frequency bands from lower to the especially higher one here. So directional behavior we can utilize it here. So the chances for our interaction we could utilize it here. But at the same time when you move to the higher frequency, our wavelength is decreasing. So why we are saying the wavelength? Because we all know that wavelength is lambda, and this lambda is equal to c by c by f here. That is the frequency. This is the speed of light, and this is the frequency here. So if I keep on moving, this wavelength will be keep on decreasing here. So when this wavelength is keep on decreasing here, so the more the higher frequency means more the smaller the bandwidth here. So it will be against the chances for the interaction with the environmental objects here or the surrounding will be keep on increasing simultaneously too here. So in such cases here. So when they are moving here, so the highly likely it will happen due to the interaction here. So the distance which they were traveling in the initial phase, first stage which are able to travel 2 kilometer or 3 kilometer distance here. So first reduction happens with the same power level. There will be a lesser distance here. Correct. And at the same time, this also offer additional advantage as if you go for the cellular communication or GSM communication here, many of you are familiar from the frequency reuse concepts here. Right? So people, what must think of? Suppose there is a suppose 20 megahertz one bandwidth is there. So we'll start okay, and so within a one bandwidth, within a one region here I will use only a set of 4 megahertz frequency. I could sectorize them. So you can say there is a complete area where 20 megahertz is utilized here. So out of that, I have divided into 10 sectors here. 10 sectors will be corresponding to the 2 megahertz, which will be corresponding to each sector here. So within a one sector, what is the 2 megahertz frequency I'm using here? I can use the same that 2 megahertz frequency again after the two or three sectors here, two or three cell here. We could use it here. So this way, we have the more directional phenomena, so there is losses associated with the signal which is traveling to us here, with from source to destination. Here the point is from source to destination, which signal is traveling. Previous cases, it was in the kilometer range here, so the chances were more for the channel effect here. Whereas it was keep on spreading here. But now, if you have frequency, this is a highly narrow beam here. So directional beam we are able to generate here. When you are transmitting the directional beam here, so the first the channel interaction time is also reduced, as well as the area which was prone for the interference here in the surrounding. That part is also reduced here. The two advantages will get when you move to the microwave here. And along with that, the additional advantage we use and get here in terms of spectrum reuse here. So now we can see what are the 2 megahertz I was using here in the one sector initially compared to now 2 megahertz I could further sector it into the further 10 here. Correct. So out of the 10 here, what is the advantage will be? One will be working 0.2 megahertz here, that's 20 kilohertz. So again at 20 kilohertz, I could use it here again to the next cell here or the sector here. So now you can have this kinds of small sectoring with the high frequency. In terms of number of users we could facilitate here will be multifold. As well, number of appliances, number of services we could also accommodate them. It could increase significantly here. And this overall, we could summarize them and club them here. We could say that the quality of service will be improved here when we try to move from one generation to the another generation here with the movement from the lower frequency to the higher frequency here. And we also know that when you move to the higher frequency here, the length of the antenna is proportional to the wavelength of the signal here. So here, when we are moving to the higher frequency, so wavelength is keep on decreasing. Moving to the higher frequency, wavelength will be keep on decreasing. And as the length of the antenna is proportional to the wavelength, so this length part will be also keep on decreasing here. So if I'm moving to the higher frequency here, I could have the chances to design a smaller antennas corresponding to that frequency operation here. As if you remember, if you go through the literature of antenna design here, you see when you design the antennas here at that time, if you see the gain phenomena of the antennas here, it is it is also proportional to the dimension of the antenna structure here. Correct. So there are ways we can enhance the gain here further, by enhancing the radiation phenomena here. Those are present here. But this enhancement will not be significant. You can slightly go for the higher values here. Here, for example, it would not be if the antenna gain is 2 dBi here, so you cannot make it 10 dBi here. You can obviously 2 to 2.5 C or like that. You can gain by the further enhancement here, but not 2 to 10 or 20 here like that. You cannot go for that here. So when you are going to the higher frequency, as we have reduced the dimensions here, now I have the flexibility to design such a large structure here, or I have the flexibility to integrate it easily with other components of the communication system here. So previous cases, if you remember, so you will always see the antenna was additional part which is placed outside here. For example, if you see the Wi-Fi router here, Wi-Fi router here, Wi-Fi router, if you see here, there is always router towards his or her room locations here. So if I summarize all these aspects here, so we can say when you are moving to the higher frequency, we'll have the first in terms of signal interference chances will reduced here, the spectrum reuse I could reduced here to be reduced here, so its integration chances with the chip or the system will be also be high here. At the same time, we are getting the highly directional wave here, so we could also reduce the chances of threads here, because now the signal is traveling within a short range or short span of area here within a short span of time here. So chances for that signal to get vulnerable attacks will also is going to be decreased here. Times if your counter action or against the person is very much willing here to explore the things here, then this chances are not nullified here. Still, it is in the wireless medium here, so it is wireless medium, so the chances are always for the security attacks here. Now, if we club all these aspects here, and if you see from the Shannon's principle here, we have discussed Shannon's is C is equal to B log to 1 plus SNR here. So bandwidth corresponding to the one operations is fixed here. So bandwidth is fixed. How we can increase the channel capacity part further here? So all the things will come related to the SNR part here. To increase the SNR part, if you see, then SNR is proportional to the power. SNR is proportional to the power here P. So if I increase the power here, I could also increase the channel capacity here. But increasing the power is not in our hand here. In our nearby surrounding or in the personal area network here, I cannot transmit beyond a certain range here. Otherwise, it will harm our health here. It will put the hazardous effect here. So in this case, it is not possible for any. Correct. But at the same time, if you see this antenna's array configuration, other perspective here, so then we'll get the chances to explore it further. So there are few cases, especially if we try to look here based on the SNR variation here. So how much it will be helpful here. In case of low SNR, if I see a log to 1 plus SNR here, so this value will be the approximate to the SNR values here. So beamforming or receiver directivity or diversity here, these are the things phenomena here. But if you see the high SNR here, in case of high SNR, this value is coming to the logarithmic SNR values here. It is coming. So compared to the previous case, low SNR here, if we go for the high SNR values here, so logarithmic SNR, so channel capacity now is going to be penetrated with this higher values here. And higher the values we are getting through the SNR here. How this SNR is coming? Just we have discussed a few minutes ago. So what are the cases or circumstances which will facilitate to go for the higher SNR values here? Correct. So to in order to increase the SNR here from all the front, we need to be attentive and we need to be work with the same objectives here. So this is what we have discussed here, ultra dense networks here. Here we could see. So we're going to see macro cells combined with the small cells. So these are the initial stages here. So initial conventional here, power here. So now you can see when you're moving from the one generation to another generation here, so you can see this first initial cell size was like this here, and with the advancement in the frequency here, now we are moving for the 4G with these kinds of small cell here. This is pico cells here. Within this pico cell, I could think of this femto cells here. Further smaller group I could formulate. So based on the application requirement here, I could go through it here. I could formulate it. So this is another representation here for the same here, what we have discussed. So another point which you need to observe here, when you're moving here for the further, then the placing of more number of femtocells as well as the picocells here will enhance our chances for the quality of service here. As we are moving here further, we are trying to go for the higher SNR here. So higher SNR values would be observed with the signal to noise ratio enhancement here. This could be achieved very easily or enhanced very easily here when we increase the more number of antennas here in the system here. So for these enhancement in the antenna system, you need to deal with the MIMO, massive MIMO, or generally we are going to deal those things in the context of antennas for the 5G here. So this is all related to the basic understanding. So at this stage, I will take a pause. If there are any questions from your side, what you discussed till this stage, any doubt from your side?
Good morning, sir. Good morning, sir. I am Arvindo Ghosh from Government Polytechnic Puri.
I think there is no questions from your side here. So I will move on. If you have any question, you can ask me. When you're moving ahead here in context of massive MIMO technologies here, then we could see this massive MIMO is not a very new concept which have been proposed by the researchers here. So as you discussed in the previous case, this antenna array here, or when you talk about the MIMO here, so MIMO array is nothing. It is the two-dimensional of the antenna array here. That's it. When you talk about array here, so array is an antenna placed only one direction here in the one configuration here. But when you talk about the MIMO here, this is a two-dimensional arrangement of the antennas here. So this is the advancement is MIMO. Or when you talk about the massive MIMO here, so massive MIMO is the further complex thing of that system here, or enhancing the more number of antennas here in that system here to accommodate this service here. So MIMO versus massive MIMO here, if we observe it, as we are going for the more number of antenna system here, so the beam forming, spatial multiplexing, those kinds of functionality will be easy for us to manipulate here. So related to the beam forming, if you remember in the previous session, a lot of discussion have been done here on the massive MIMO and beam forming things here. So I will not go in detail of beam forming here. So, whatever the point is, when you are moving from the one antenna to the another antenna, especially from when you talk about the MIMO here, generally we take 2x2, 4x4 MIMOs here, correct? So, suppose there are four antennas here. So, corresponding four antennas, you have the four beams corresponding to those four antennas here, and I have to need to manage those four beams in the different directions here. This is the one aspect here. Now, if I increase that number from 8, 12, 16 here, this if I increase, then I have the 8 number of beams with me, and I need to play with all those beams here. So based on the different excitation feed here, feeding I can provide to them here, I could have the functionality to club them here. I have the functionality to segregate them here. They will be transmitting with respect to totally different with respect to each other here. So for example, if we see this figure here, so when I am talking about the multiple antenna system here, so you can think of in this system, there are I think 10 antenna system. Yes, 10 antenna system it is here. So corresponding to 10 antenna, I have the 10 beams with me here. Correct. And these beams could be associated with the specific user also here. So I can say the 10 antenna which is present here, one antenna will be associated directly with the one user requirement here. As these beams which are generating here will be just in the nearby bands to that here. So this kinds of coupling we should not be present here with this because in terms of frequency we already segregated them here. So once we have this kinds of architecture and we are increasing number of antennas here, we have the more liberty in terms of quality of services here. We could facilitate the user in terms of their operability here, correct? Mm. And as we are moving to the higher frequency advantage will be present with us here. So the more number of antennas, the more adaptive beamforming functionality will be with us here. So more number of users as per their requirement, I can accommodate them here. Correct? So this is the one example here whenever we're constructing the new structure from the antenna array configurations here. So two-dimensional antennas array here, where 8 cross 8 structure within two layers have been demonstrated here. So 16 ports will be there here, and the spacing between them is 0.8 millimeters. So this is the another explanation here based on this. So here you can observe when you are moving from the MIMO to the massive MIMO system here. So in case of MIMO, you can see at present we are going to the small cell, and then further we are going many small cells to the femto cells within the cells here. So as we can observe, when you talk about the MIMO here, so the symbolic presentation, you can observe the number of antennas which is only 4 or 2 like this. You will observe in the pictorial form here. So this is the indication when you are using the 4G technology, we are using the MIMO already here. So the number of antennas which is deployed here is only number of 4 antennas we are using here. But when you talk about the 5G here and we are increasing, so now you can see at the base station here how many number of antennas will be present here. So this number will be significantly more at the base station here. If we talk about the base station perspective here, people are talking about the 128 or 256 kind of antenna system here placing at the base station here. So once we have this much high number of antennas placing at the base station here, then we need to also deal a lot of uh, 5G network. So 5G network will be very important here. 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 So 5G networ other issues which will arise here by placing so many antennas within the surrounding of each other here. So this will be really challenging aspects here when we need to accommodate more number of antennas. As we all know that when you are putting the multiple antennas in its surrounding here, at that time, this chances for their mutual interaction will be highly likely. So this mutual coupling part is arises here, or mutual interaction, or the isolation part which we do here. So when you say the mutual coupling here, so mutual coupling will be present between mainly due to the two nearby antennas here. What has happened when you are one antenna is transmitting? Suppose one antenna is transmitting here. So at transmitting, then at that time, what will happen? Is the one antenna is transmitting, and there is another two antenna here. So in this case, what when this antenna is transmitting here, then whatever the electromagnetic waves are coming here from this antenna here, there will be chances it will get an interaction, or it will some part of this energy will be towards this antenna system here. So this will interact. Similarly, when this antenna is transmitting, some part of this energy will come to your receiver sensitivity, or if you want willing to receive some threshold power here. So those power will not be received properly here, or you can say some irregularity in decision making process will be arising here due to the saturation of this receiver here. So all those issues need to be avoided here. So when we are putting the multiple antennas in place of two, I am talking about the 128 antennas placing here. So I need to be so attentive about these kinds of mutual coupling issues here. And this is one example here related to the massive MIMO system. If I look in the system here, you can see this is a 128 antennas is placed here in order to formulate a base station corresponding to the massive MIMO system here. Base station antenna system 128 antennas have been placed. Now you can think of a system like this, correct? And all of them have been boxed properly here so that they will be segregated with them here. So coming out. So the other isolation as well as the interference chances is minimized here by putting them in the separate casing here. See, the antenna design aspects is the 5G here. By considering all those aspects here till date, till our discussion here, we could say from the 5G as the frequency is increased, so electrically small antennas here will be available for us here. But at the same time, this antenna need to perform the desired characteristic which you're looking from the 5G perspective. Better matching without matching circuitry here. So within the design, can we do something or place some circuitry here in the design part itself here, so that the matching will be proper here? Because if you remember, when we are going to feed the antenna here, at that time, if you all know that the standard frequency or uh, the standard impedance is only 50 ohm values here. So if it is your circuitry value is not 50 ohm here, in that case it will lead to the losses here. All know that reflection is gamma is equal to ZL minus Z0 divided by ZL plus Z0 here, where ZL is the external components which impedance is there, and Z0 is the circuit. Z0 is 50 ohm, it is fixed here. But what is the value of ZL component of circuitry I am designing here? So this need to be also approximately equal to the 50 ohm values here. So people generally when you go for design here, but it's designs external circuitry values not 50 ohm, so they put some additional circuitry or go for some kinds of tapering mechanism, tapering phenomena for the gradual change in the increment in the impedance value here. Correct. So these kinds of technology people, again, like, solution people used to provide here in order to reduce these kinds of losses here due to the reflections here. The in-band coupling reduced with the electrical separation here. So nearby bands here, so interaction need to be reduced here. Device integration, as the devices are small here, we could also always integrate it, but we have to be very careful from their power aspects here. Need to achieve high gain requirement, more sophisticated feeding control circuits, as well as in the last and very important, good isolation between array elements must be achieved here. So these are the few. So any questions from your side? Well, after that, we will see a few of the practical examples here. No? Okay. Okay. So let us see uh, what could be the other aspects, the design here. So when I see this structure here, this is one example which is proposed for the 5G massive movement antenna array here. So when we talk about the 5G antennas array, there are two aspects. One is related to the design of base station for the 5G perspective here, where you need to put design structure in the context of 128 or 256 antennas placing here. That is the one aspect, but generally the lab here on the academic institution, this kind of facility or space is not available where we can go for such a large structure here. Correct? Okay. So generally in that case, we twist to the another aspect of the design here, which is a little bit possible for us, if feasible for us also to design it here. That is the designing of the antenna for the mobile phones here. So this is the few of the examples which I'm going to consider here. This is based on those aspects here where we could will take of the possible solutions here for this solution in the future here. One part here, one project part here. So where they have used a patch antennas here, correct? So in the patch antenna, they have deployed 12 antenna systems here. Out of the 12 antenna system, they have placed the similar kinds of antenna with some separation, and other frequency band antenna they have placed in middle of it here. So here they have targeted LTE 42 and 43 bands here in the operation. So based on that operation, they are observing these two frequency bands here. LTE band 42, 43 at the one side, at the in the 3.5 megahertz, uh, 3.5 gigahertz. Another frequency band, LTE 46, around 5.5 gigahertz. So these two bands they have targeted here in the respect of the 5G technology appliances here. So in order to achieve these two separate bands here, they have deployed two separate antenna structures here, right? So one antenna's geometry is different compared to the another set of antenna set geometry here. One set of antennas will be working here for the 42, 43 bands. Another set of antennas is working for the 46 band here. So here there will be another antenna which will place at the corner here, which will correspond 2G, 3G, and 4G antennas compatibility issues here. So because whatever the telephone, mobile phones we are designing, it to be compatible with the previous processor here. So as many of the devices are working in this band here, so it need to be in that bands too. Yeah. So these are the few of the results corresponding to these here. So as parameters are like this, frequency as well as this dB values. These are the radiation pattern values. You can see radiation behavior values they are observing here. So they can see many of them was just in the omnidirectional behavior they are demonstrating, and which is good from the 5G antenna perspectives here. So it will be able to catch the signal from all the directions in a plane here. Another 40 to 43 bands in LT 40 to 40, 43 and 46 bands. They have demonstrated the major results. Still, it is matching or it is acceptable as within that range here. Another design aspects could be 12 antenna MIMO arrays for future 5G technology here. So this is the one design where people are using a set of antennas here. Again, 12 antenna system they are also using here. So similar set of antennas they have placed at the four corners, and few other antennas have been placed in nearby to them here. Just keeping a note just so that the minimum isolation among them need to be present here. So based on that, they have targeted the 3.5 gigahertz band for the 5G here. This is another example here, 5G antennas for the smartphones they have proposed. So where they have used the SIW polarized mesquite antennas here, and this is slotted wave. This antennas arrays here. They have used it. It's another example where they have used dual feed square loop antennas for 5G, correct? And this is another antennas here, matching for the power macro network here. So loop antennas kinds of structures they have proposed here, and still they are obtaining some kinds of omnidirectional behavior here as a response here. And this structure is not designed for the sub 6 gigahertz here, but they have targeted more than 30 gigahertz range here. So they are proposed in around 35 gigahertz frequency range here. The 5G wideband patch antenna here. So in this proposed and within this range here, they have generally accommodated some other standards, and based on that standards here, they have targeted the range of 1.7 to the 2.7 gigahertz, 1 gigahertz bandwidth range here to accommodate it here. So this is not you can say two-dimensional structures they have proposed compared to the one-dimensional patch here modified. So these are few of the popular test beds: 5G test bed, erection 5G radio test bed here. These are the Nokia's test bed here. They have also provided the solutions. They are also the leading researchers here. So, any question up to this point?
Hello, sir. Good afternoon.
Question is coming.
Sir, good afternoon.
All of you are connected or disconnected?
Hello. Hello, sir. Are you getting my voice?
Am I connected or disconnected? Am I able to audible to all of you?
Yes, sir. You are audible.
Audible, sir.
Okay. You people are so silent here. Sometimes it feels out. It is going to be one way or it is still two way. Okay.
Hello.
Anyway.
Hello.
Okay. Thanks for your responses here. So before we conclude here, so let us see a few of the 5G test bed facility here, which is present here. So Nokia is one of the leading solution provider here. Previous slide we have seen about the Ericsson's. Ericsson is one which is also taking lead in the design development of 5G technology. Nokia, they are the well-known technologies here. National instrumentation in here, They are always the leading solution providers here in these kinds of evolution of technology. They always come forward here. So these are some of the test benches they have proposed for the academic. What are the properties associated those algorithms here. Here are the few R&D centers here corresponding to these other different activities related to 5G. And the last, let us discuss a few of the research possible problems here related to the 5G antennas here. So as we have discussed, in any antenna system, the optimization and dimension will be the one part here which will be people looking explicitly to explore always the miniaturization in the design part here. So this part will be always desired in case of antenna design perspective here, and still it is holds true here in case of 5G antennas too here. Second is mutual coupling reduction. In case of mutual coupling reductions here, so when we are placing the multiple antennas side by side here, so the beam interaction will be taking place here. So how we could minimize the interaction between the nearby antennas here, as they are operating in the same range of frequency. In the functioning here, so beam forming or spatial multiplexing, these kinds of phenomena, wherever you can see the real-time manner, how we could design system here, so the beam forming will be managed as per the requirement of the user here. For example, if some user is looking for the more bandwidth here for the service later regarding queries here, then additional bandwidth or additional focus could be provided. Or whenever someone is just using messages, kind of data messaging here, someone looking for the video calling kind of facility here. So based on that, proper quality of service, additional beam width need to be provided, proper linkage of the bandwidth as well as the associated linkage between the source to the transmission need to be taken care of. Next is body and network here. So it's a lot of things related to the when you place the antenna near the body here, you need to look at this part here. Here, okay, okay. Okay, I just forget to attach it here. So when you see the research problems here, so a lot of possibility will be rises here. One is optimization in dimension, then mutual coupling reductions, reconfigurability in functionality here. So we can minimize the dimension. We could always go for the interaction minimization between the nearby antennas here, as well as reconfigurability in the functionality in terms of beam width, in terms of their spatial multiplexing here. Okay, so some questions. Okay, so okay. So please let me know what are your questions.
Hello.
Yes, please.
Am I audible?
Yes, you are perfectly audible. I think some queries came. I was not audible.
Yes, sir. At that time, we were asking, but I think you are not able to listen our queries.
Okay, okay.
Okay. So my question is that if we are increasing the number of antennas, like 12 or 24, then how they will be accommodated in mobiles? Because in mobiles,
Yes.
now mobiles are now becoming thinner, smarter and small. So if we are increasing the number of antenna, then space problem and accommodation problem may be arise.
Perfectly correct. So I think this is a very fundamental questions here related to the 5G technology here when are moving ahead here. So people have explored different kinds of solutions here, but what is the solution available at present here? The people are coming with a slot antenna kind of solutions here, which seems feasible at this stage here to accommodate more number of antennas here. If you go through the literature here, see some of the recent papers which is coming here. So this slot-based antenna is coming as a feasible solution compared to our conventional antenna design system here. Here, if you remember, so what are the few slides I have demonstrated here? Yes. If you see this structure here, if I could enlarge it further, you see. Okay. If you see these kind of structure, there is one part they have clearly complete. Another green section is you are saying this is a complete patch ground at the one side here, and from the ground, so the coaxial feeding they are feeding is these structures here. So coaxial feed, you can say antennas 8, antenna 9, 10, 11, which are written here. This is a coaxial feeding we are providing, and this is a small segment of structure here, which is we are using in the slot antenna kind of manner here. So this is the possible solution of slot antenna kind of solutions here to accommodate more number of antennas here. Otherwise, if you go for the conventional patch antenna design here, then it is not possible to accommodate more number of antennas here. I think you can go for hardly 4 or 8, not beyond that here. And the same is when
Hello, sir.
yes,
I have a question.
just a minute. I have not answered complete here, so I have just given the answer little design. And still part is mutual coupling. He asked the two question in the single one here. Related to the mutual coupling aspects here, so if you look here, so the antennas which are placed here, they have designed the antennas for the dual frequency. So you can see there is two operating bands they are obtaining, LTE 40 to 43 and LTE 46, correct? So the one antenna, suppose antenna 8, 10 and 12 are working at the one set of frequencies, and these antenna in middle between them, antenna 9 and antenna 11 are working at the another set of frequencies here. So that's way they have differences. So two antennas are placed to each other here, but they are working in the different frequencies, so their isolation will be minimized here. So on that way they have processed. I think I have given the answer for your question, Dr. Nipur.
Yes, sir. Sir, what measurement facility is available at Triple IT?
At Triple IT, we have the facility to go for the PCB. We have the anechoic chambers too here. So here you can we can fabricate it and the measurement here. So we have the VNA spectrum analyzer, power source up to 14 gigahertz. We have the VNA. We have power source. We have the high here. So up to 14 gigahertz measurement facility we have, and still we are planning to explore it to the 30 gigahertz. In the I think next one year we will be able to go for the 30 gigahertz.
So is it available to outsider also, or it is only for the?
At this stage, still it is not provided outside here. But if the request come here, we could move on those requests to here. If anyone is willing to explore these facility here, so we could make a provision for them to here. That is not a problem.
Thank you. Thank you.
Thank you. The next question.
Good morning, sir. Good morning, sir.
Good morning.
I just have a question. Like, if frequency range increases, then how much increment in SAR, increment percentage we will get in SAR? So SAR will also increase. How much increase will that happen? And sir, if number of antenna increases, so congestion management will also, I think, will increase. So how much, sir, how will that affect the present scenario, and how much changes will happen in those sectors, sir?
Actually, first thing you are asking here, you ask for the very quantitative data related to the enhancement here in terms of SAR values here. So as we observed the present scenario, if we are moving ahead here, so the SAR values will increase here with respect to the enhancement in the frequencies here. So some of the initial studies, simulation based, we have done here at our institute here in the lab here, where you observed the moment we move from the lower frequency to the higher frequency, there is an enhancement in the SAR values here. So there is a direct relation you can see. And the more the number of antennas you are putting here at the same time, then and this value will be keep on increasing if you are keeping the same power level. So I'm repeating again, if you keep the same power level which you are providing earlier, if you keep the same power level at the each feed, then the SAR value will be high. But once you go for the multiple antenna systems here, at that time we have to also optimize the power levels too. Where the same power level you cannot work on it here, because there is so much amount of power with the cumulative, it will be hazardous to the health here. So you cannot move on with the same level here. So you have to also optimize the power here. So our like institute here, this is some preliminary studies here. So we are trying to explore it further so that maybe next time when we meet here, I could give the exact quantitative data related to the your questions here. But at this time, I could say qualitatively, with the increment in the frequency, this SAR values increases, as well as with the increment in the number of in antennas also, SAR values increases here. I hope I have given the answer, or still I missed something.
I've got that.
Okay, thank you. Any other question?
Hello.
Sandeep,
Sir, how
namaskar.
are you?
Good morning. Tell me.
My question is related to the base station antenna for 5G.
Mhm.
As we have explored, there will be many antennas that will create multiple beams. So in case, because we have to cover the entire area, these beams must overlap with each other so that no space is left without any coverage. So
Correct.
what are the chances that the beams will interfere with each other? So there may be chances of interference also, because
Okay.
multiple beams covering the entire area, so we cannot leave any area uncovered. So we must have overlapping beams. So
Correct.
is is there any drawback of interference also here? So that is only my question, sir. Thank you.
Yes. So that is a very nice question, Sandeep. You ask here. Later, so people have misconception here. But when we trying to move for the 5G technology here, there is a adaptive beam array configuration or concept people used to coin the terms here. It means as when we are going to the base station, there will be set of frequencies here associated with that here. So as we all know that whenever we go for the two beams, suppose if I consider these two beams here, let me mark it, this one here. Suppose if I take this beam as a 1 and this beam as a 2 here. So corresponding to this beam 1 and 2 here, if I say, if this is working as a frequency f1, this is working at the f2 here. Then the chances for the interference between these two beams will be reduced by the nearby bands frequencies here. Because still, if they are nearby bands here, then I could say there will be chances. So first you are asking if both are working in the same frequency, there will be highly likely chances they will have the interference. If these 1 and 2 are working at the frequency, one is working f1, another is working f3. If I suppose there is a set of frequency f, I divide it into 10 frequencies, 1, 2, 3, 4, up to the 10 here. If there are 1 and 2 here, then still there are chances a nearby band coupling will be present here. But if I go to the 1 and 3, then this near low chances that they will have phenomena in the team it's designing itself here at the time of service providing. So this will be totally adaptive in the such a manner so that the two nearby frequency bands beam will not be close to each other to cause a interference here. Is that an answer for your question, Sandeep?
Yeah, perfect, sir. Very nice. Thank you, sir.
Okay. So any other question? No? Okay. So there's no further questions here. So I assume at this stage here. I would like to close this 13 technical session of the morning first session here, fifth day, on the antennas for 5G here. So now I will take 5 minutes break. So again, we will start after 5 minutes break on the next technical session here on the IoT and wearable antennas. Okay, for having your patience and listening. Thank you.